Hello and welcome. I'm Andreas. I work as a trainer and consultant primarily for C++. And I'm also the creator of C++ Insights. And this is also the tool I like to talk about in this series. C++20 added a feature called designated initializers to C++. And this is what I want to talk about today. In general, it's not new. Maybe you've used it because C has its own variant of designated initializers. They were there from more or less the beginning. I'm not totally sure about that, but way before C++ added them in C++20. However, they work a little bit different, so I will focus on designated initializers in C++ only. So what we can have here is we can have a aggregate, a struct point here with three data members x, epsilon, and z. And then I'm using that for creating a point p1. And this here is the notation for designated initializers. I can now say dot epsilon equals 3, and I can say dot z equals 4. So this only works with curly braces. And as you can see, I omitted the variable x deliberately here. Now, thanks to the curly braces, I have the guarantee that x gets initialized with its default. So default constructed or 0 or an equivalent to 0. For the other data fields, I provided an initializer. And this now gives us the ability to omit a couple of data fields here and only initialize the ones we want to have a non-default value for. So if I transform this in C++ Insights, you can see here x gets initialized to 0. One nice benefit from this notation here, from the syntax, is that we now can name the initializer so that we know the first one is not x, the first one is epsilon in this case, and the second one is z, which is equal to the third field in my struct. Without designated initializers, the data fields would be initialized differently. So now epsilon still becomes the value 3, but now x would have the value 4 and z 0. So this is something that you might run into the past as an issue. Now we have the ability to precisely specify which data member we want to initialize with which value without still having to write a constructor for point and going down this road. What you cannot do in C++, but you can in C, is flipping the initializer. So you cannot initialize or name z before epsilon. It's more or less echoing what you have in a constructor initializer list. The members must be initialized in the order they have been declared. Otherwise, you might look at an out of order definition or initialization. So the compiler here below, in our case Clang, tells me that this here leads to a warning because C++ here requires the designated initializers being specified in declaration order, but C allows the notation I have written here, and because our C++ compilers are compatible to C, they allow this feature. But remember that it's not C++, you might run into trouble because C++ has constructors and destructors, so lifetime, object lifetime in general, which C doesn't, so that makes C simpler in some cases and allow the flipping here, which I understand can also be very nice, but it's dangerous in C++. I hope you learned something today that you can apply to your C++20 code base, and I look forward to our next episode. That's it for today. Stay tuned for the next episode. Bye bye.